to transformations of graphs lecture. Okay. I apologize. I got to teach from my desk today, unfortunately, since my iPad's just about dead.
Oh, you didn't charge it last night?
I left my charger here at school. My apology. It's a good question. I didn't charge it last night because I was sleeping. Okay, so transformation of graphs. All right. So, yeah, this is a transformation of graphs lecture. There we go. Okay. So, basically, the way you guys have always graphed from since Algebra 1 is, I believe you guys have just been taught, yeah. Notes are on Schoology as well, yeah, in the MISC topics, the yellow MISC topics folder. So the way you've been taught to do this in Algebra 1 is you make like a t-chart, and you take your equation, you make a t-chart, you pick some values for x, you plug them into the equation, you get out values for y, you plot all the points, you connect them with a line, right? All right, so now we're going to teach you a different way of graphing functions. It's a little different, but you do a lot of it in pre-cal. Basically what you do is you start from what we call a parent function. You look at your equation, you see what parent function it's related to, and then you see if there's like a plus or a minus or a multiplication by some number. We're going to show you how that changes the parent function and gives you your new graph, okay? So probably don't understand it based on what I just said, but hopefully today's lecture will clear that up. Okay. Yeah, so I want to talk about a function family, okay? A function family is a set of graphs which is related to the same parent, which comes from the same parent function, okay? They have similar forms, similar shapes, okay? So these are all linear functions, right? Look, they're all straight lines. So we say they're part of the same function family, okay? These are all part of the absolute value family. Right? Because they all look like beads. Either upside down or right side up. Okay. Right, okay. So the parent function is going to be the simplest function in a function family. So for linear functions, the simplest linear function is f of x equals x. And it's just, I actually drew half of it here. Right? It's got slope of 1, y-intercept of 0. So it's just straight diagonal line like that. Okay, the most basic absolute value function is f of x equals the absolute value of x, right? That's just going to look like a little v here. Just a v, okay? Following this so far? These are the most basic linear functions and the most basic absolute value functions, okay? And here's how this works, okay? So I'm going to go ahead, I'm going to graph the parent absolute value function. So just y equals absolute value of x. I'm going to do that on my graphing calculator here, okay? So that blue graph right there, that's the graph of y equals absolute value of x, the parent absolute value function, okay? Okay? And so now we're going to look at these seven problems here, okay? We're going to see what they do, okay? So if I graph the absolute value of x plus 2, so it's just like the line above it, there's a plus 2 there, right? So that red graph is the absolute value of x plus 2. What did that plus 2 do? What did that plus 2 do to my original graph? Yeah, it moved it to the left, right? That red graph is now shifted to the left 2 from that original blue graph, okay? So it shifted me left 2, so shift left 2. Right? Alright, let's see what happens if I change that x plus 2 to an x minus 2. Let's see what happens. Now where's the red graph? To the right of the blue graph. To the right of the blue graph. Alright? To the right of the blue graph. Okay, so it shifted me to the right too. Shifted me to the right by 2, okay? We all see that? Are we having trouble seeing that, right? That red graph is just like the blue graph, but it got shifted to the right by 2, okay? Now let's look at, so now let's do absolute value of x plus 2 again, but instead of having the plus 2 inside my absolute value bars right next to x, let's put my plus 2 outside my absolute value bars like that, okay? What did that do to my blue graph? What happened to the blue graph? It got shifted up by 2 now, yeah, so shifted up 2. Shifted up by 2. Right, similarly, right, what do you guys think is going to happen if I change this plus 2 to a minus 2? It's probably going to go down, yep, so that red graph got shifted, that red graph is just the same thing as the blue graph, except it got shifted down by 2. Got shifted down 2. Okay, so shift down 2. Shift down 2. Alright. Good stuff. Anyone have any guess what happens if I graph 2 times the absolute value of x? So instead of adding or subtracting something, I'm just multiplying. Anyone want to guess what's going to happen? So if I hit the graph button, look at that red. So the blue graph is my original parent graph. That red graph is if I multiply the parent graph by 2 and graph it. What happened? It got a little steeper, right? So what really happened is the graph got like vertically stretched. It got stretched by a factor of 2. So vertical stretch by a factor by 2.
Wait, for the. We gotta go with that. Can you just say like the slope increase or something?
No, because we want to talk about functions in general, and not all functions are straight lines. So if you have like a parabola and you multiply the parabola by 2, like that, it will stretch it by 2, but like it won't have a slope to increase. If that makes any sense. So we're going to try to generalize this later. Yeah. Yeah. So vertical stretch by 2. Vertical stretch by 2. Right. The graph just got twice as tall. Likewise, what do you think happens if I multiply by 1/2?
So the answer is the red graph?
So the red graph is like the problem. So for number 8, we graph the red graph, and we're just comparing it to the original. The blue graph is like the parent function.
Okay.
So I took my parent function, the blue graph, and I multiplied it by 1/2. And what did that do? What did that do to the red graph? Yeah, it made it shorter. So it compressed it vertically. Vertical compression by 1/2. Okay. Right. Let's see then. All right. So number 9. Let's check out number 9. Let's see what happens if I take my parent graph and just multiply it by -1. If I just put a negative in front, what happens? It just flipped. Right. It flipped across the horizontal axis. So that blue graph just flipped right over, became that upside down graph right there. Okay. So flipped over horizontal axis. Now flipped over the horizontal axis there. Okay? Good. So we'll see there's going to be 3, and we saw all 3 types here. Okay, there's going to be 3 types of graph transformations. Okay, if we add or subtract something, that's going to go ahead and translate. It's going to be a translation. A translation is going to just slide our function around. It's not going to compress it or stretch it. It's just going to slide it around somewhere. Okay. A dilation we call number 7 and number 8. We call those dilations. A dilation, that's going to be you're stretching or you're compressing. It's going to smush your graph, or it's going to stretch it out.
What's an example of translation?
Translation, so number 3 was an example of a translation when our parent graph got shifted to the left by 2. So I can pull that back up. Yeah, so there was an example of a translation. Just got shifted to the left by 2, okay? Alright, so dilation is going to stretch or compress your graph. reflection flips a function. It just, that was number 9. It just flipped our graph, our parent graph, over the horizontal axis. Okay. So we feeling okay about this stuff so far? Any questions? So the new stuff, this is not review anymore, but hopefully it'll be helpful. We can start to understand it, okay? So let's think about what happens in general, okay? So when we have a function, okay? So I'm looking at this first line here, f of x plus h. When we have a function and x is inside a pair of parentheses, right? If we put a plus h there, right next to x inside of parentheses, or in this case, inside our absolute value bars, it translates the graph right by h. Or let's get these left, sorry. Translates graph left by h. It is opposite when we're moving left and right. It's the same when we're moving up and down. So a minus h inside my absolute value bars or inside my parentheses next to x is going to translate the graph right by h. Alright, and then notice the difference here. When I add k, that k is not inside my parentheses next to x, or it's not inside my absolute value bars. It's going to be outside my parentheses or outside my absolute value bars, okay? So that plus k, when I do a plus k outside my parentheses or outside my absolute value bars, that's going to translate my graph up by k. Likewise, minus k is going to translate my graph down by k. Okay? So notice, right, when we're moving left and right translations, they're inverted. So a plus h inside my parentheses next to x moves me to the left. A minus h inside my parentheses next to x moves me to the right, so it's inverted, it's opposite. And then when we add or subtract something outside the parentheses, it's the same. So adding something moves me up, subtracting something moves me down. All right. Okay. And then dilation, when we multiply our function by a number that has absolute value greater than 1, so 2, 3, 4, 5, or like -2, -3, -4, -5, that's going to vertically stretch it. So my graph is going to be a times taller if I multiply it by a. So if I multiply my graph by 2, it's going to be twice as tall. Likewise, when we multiply our entire function by a number whose absolute value is less than 1, so like 1/2 or 3/4 or -4/5, that's going to vertically compress my graph. It's going to make it shorter. Alright. And then anytime I multiply my function by negative, that just reflects graph over horizontal, graph across my horizontal axis. Alright, so give you a couple seconds to write all that down. It's kind of a fire hose of information. Fire hose of information. Alright, hopefully we'll process it better when we look at these example problems down here. So let's look at number 10, example 10. F of x equals the absolute value of x minus 3. First of all, looking at all of these, all 8 of them, what's my parent graph that I start from? My parent graph.
Absolute value of x.
Yeah, f of x equals absolute value of x. Yep. Okay, and then when I take absolute value of x and I do a minus 3 outside the absolute value bars, what happens to my graph? would be to the right if it were inside the answer bar. Yeah. Down 3, okay? It's translated down 3. Alright, and then number 11, right? I got a plus 7, but it's inside my absolute value bar, so what does that do? Translates left 7. Yeah, translates left 7. Yeah, translates left 7. Number 12. Number 12's got 2 of them, right? What happens to 12? Yeah, so it reflects, and this minus 4 inside my absolute value bars, what does that do to it? It translates right by 4. So it translates right 4. And then reflects over horizontal axis.
We're gonna write all of that.
Yeah.
Like, can I just write reflects and translate to the right?
Yeah, I mean, it's your notes. You can write whatever you want. So whatever.
But like, when we start doing
What's that?
to turn in,
Oh, to turn in like on a quiz or something or a test. Yeah, you need to write the number of units to translate in what direction.
yeah, that's not what I'm saying.
Oh, I'm sorry.
Reflects over horizontal axis.
Yeah.
Instead of saying all of that, can we just say it reflects?
No, you want to say the horizontal axis. Definitely want to say the horizontal axis. Because there's going to be situations when it does the vertical as well. And pre-cal, you're going to have to know. Yeah, pre-cal, you're going to have to know. Yep. All right, number 13. Number 13, I have a multiplied by 4, and I did a plus 1 outside my absolute value. So what does that do? What happens with 13?
Dilate.
Yeah, it's going to dilate, so it's going to vertically stretch, right?
Because it's greater than 1?
Because it's greater than 1, yeah. If
Which
the number is
number?
greater than 1 or less than negative 1, it's going to vertically stretch.
What number are you looking at to see which one's greater than 1? 4 or 1?
4. The one that gets is the multiplier. The one that gets multiplied is the one I'm looking at to see that it's greater than 1. Alright, and then that plus 1 outside my absolute value bars. Plus 1 outside my absolute value bars, it's going to translate me in what direction?
Which one?
Down low. Down low.
It's a plus 1 outside my
Oh,
absolute
yeah,
value
up.
bars, so it's going to be up 1. Yeah. It's going to be up. Translate up 1. Number 14. What happens here? It's going to compress, right? Because that one, it gets multiplied by 1/3, and 1/3 is less than 1. It's between negative 1 and 1. Right? Absolute value of 1/3 is less than 1. Okay? So it's going to get compressed, so vertical compression. So it gets 1/3 shorter. Right? Number, you guys okay if we move on to 15, or do you need to slow down? Right, 15, what happens here?
Translates left and down.
Yeah, so that plus 2 inside my absolute value bars translates me to the left by 2. That minus 5 outside the absolute value bars translates me down 5. Translates me down by 5. Okay, and then number 6. 3 things happen here, right? I multiply, so I'll rewrite this as negative 1 times 2 times absolute value of x minus 1. So what happens first? What's inside the absolute value bars next to x?
Translates right.
Yeah, it translates right 1. Translates right 1, and then that 2, what does the 2 do? 2 does.
Stretching.
Yeah, it's going to vertically stretch it by 2.
So the negative's not with the 2?
So it is a -2, but the negative reflects it. It doesn't stretch it at all. If that makes any sense. So it doesn't do the same thing that the 2 does.
So then you don't contrast because
It stretches. Okay, so I think I need to do a better job making that distinction. It does reflect. Let me write that down first. Yeah. So it doesn't compress. I'm going to explain. It does reflect. Yeah. Reflect over horizontal axis. Yep. So that number in front, right? -2 is less than 1, but it's also less than -1. We're looking at the absolute value. Absolute value of -2, which equals +2, is greater than 1. Yeah, so it's all about the absolute value of this number in front. It's all about the absolute value of it. So if it's, let's look at a number line, right?
wait, what?
Right? If the number is inside this region on the number line, and f of x gets multiplied by it, right, that's going to compress. It's going to compress the graph vertically. If it's outside this region on the number line, so greater than 1 or less than -1, it's going to vertically stretch your graph. Okay, so -2 is less than -1. It's outside that region, so it's going to vertically stretch my graph. Yes.
So basically, if it's a fraction.
I think you're thinking about it the right way, but I want to say like something like 7/5, right? That's greater than 1. That's a fraction, but it'll still stretch. But I think you're on the right track, thought-wise. Okay. Sound okay? Okay. Sorry, I got to teach from my desk today. I don't like doing it. Okay. And 17. Yeah. So here's a good example of Tom's question. 4/3. Is that going to vertically stretch my graph or compress it? Yeah. So it's a fraction, but it's a fraction that's greater than 1, so it's going to vertically stretch. Vertically stretched by 4/3, and that +2, what is that going to do? Translate me up, right? Yeah, so if it's hard to remember left and right versus up and down, just look at your chart here, okay? A +2 outside my absolute value is going to translate the graph up. Okay? So that's one type of problem we'll see here, right? They give us an equation. We have to describe what happens to the graph. And then another problem is they're going to describe what happens to the graph, and we have to give them the equation, okay? So it says that the parent function is f of x equals the absolute value of x, so we start with that. And then how do I take my, I'm going to highlight this P. How do I take my parent function here and translate it 6 units to the right? What do I?
-6.
Yeah, exactly. So I'm going to write f of x equals, and then inside the absolute value bars next to x, I put a -6. That's going to translate my graph to the right. Okay, so we're just going backwards now. Right? And then if I take my parent graph, right, and I want to reflect it across the x-axis and then translate 2 units up, what do I have to write in here?
Negative.
I gotta do a negative. The negative's gonna flip me across the horizontal axis, and then translating 2 units up, what do I have to write in?
Outside of it.
Yeah, +2 outside the absolute value bars, exactly. Yep. Sweet. All right, vertically stretched by a factor of 5, and then translated 1 unit left.
5 times absolute value.
Yeah, yep. That +1 there is going to translate me, right, that +1's inside my absolute value bar, so it's going to take me to the left by 1. That 5 right there vertically stretches the graph by a factor of 5. Right. Number 21, right? There's 2 translations here. What are they? So 3 units right and 4 units down. So where do I put the 3 units right?
Inside.
Inside. So -3 inside the absolute value bars. The 4 units down.
Outside.
It's going to be a -4 outside the absolute value bar. All right. Number 22. Vertical compression by a factor 2/3. What's that?
2/3. Outside.
Yeah, 2/3. It's going to multiply by 2/3 outside the absolute value. And then we got to reflect across the x-axis, so that has to be a -2/3. So the 2/3 does the compressing, the negative does the flipping. All right, 23, vertically stretched by a factor of 2, translated 9 units down. The vertical stretch, where do I put that? By a factor of 2? On the outside, yeah, it's just a multiplication outside the absolute value bars, and then translating 9 units down is going to be -9 outside my absolute value bars. Absolute value bars. All right, 24. Vertical compression by a factor of 1/4. So how do I do that to my parent function? Yeah, multiply by 1/4. Absolute value of x. Shifting 1 unit to the left, so I should. If I get +1, shifting 1 to the left, I got to do a +1 inside the absolute value. That's all she wrote for today's notes, okay? So if you guys want to get a head start on your homework, it's probably not a bad idea. It's probably not a bad idea to get a head start on your homework, see what you're confused on. Yes, and yes.
Can you go over the break for the next?
Yeah, let's talk about that, yeah. Basically, so this is like a new way of graphing stuff. So the way it works is like algebra 1, like they give you like an equation, like y equals x plus 2, and you make like a chart, and you have like x values you pick, you plug them in, they give you y values, and you plot and you draw a line. This is a little different. So the way this method of graphing works is you start from like a parent, we call a parent function, and then so that we started from right f of x equals absolute value of x there under in that box. We start from a parent function, and we know what that graph looks like. That looks like parent function there looks like this. Yep. So that's the graph of the parent function for absolute value, and then we can figure out what these graphs look like by starting from the parent function. And then asking ourselves, like, what does this +2 do? Okay, it's just going to shift us to the left 2. So this new graph here is going to look just like this absolute value graph, but it's going to be shifted to the left 2. Does that make any sense? Okay, cool. And we can do the same thing for lines. So the parent function for lines is f of x equals x, right? F of x equals x there.
So.
And then the graph looks just like that. It's just like a line with a slope of 1, y-intercept of 0.
So left is plus.
Inside your absolute value, or inside your parentheses. So those are all linear functions, those are all absolute value functions. Yeah. Yeah, they're both just a positive number multiplied in front, right? The difference, this 2 is greater than 1. It's not, on the number line, it's not between -2 and 1. The 1/4 is between -1 and 1.
So what that's
yeah. Yeah, so if I took your height and multiplied it by 2, you'd be a lot taller. If I took your height and multiplied it by 1/4, you'd be a lot shorter. That makes any sense.
So yeah. So if it's greater than 1,
Yeah. Yeah, exactly. All right, cool. I got a good video today.